Alright? Now, we talked about yesterday what all situations could not be the base. Why can that base not be a 1 in exponential? Be a horizontal line with it. Why can it not be a negative base? They fluctuate, oscillate. Very good. You go back and forth between positive and negative numbers. Okay, if it's increasing, it's exponential what? Growth. And how do you know that your base is a what? Whole number. If your base is a fraction, it is doing what? Decaying. Okay, decaying. Alright? So on this particular graph, we already know our domain's going to be what, guys? Okay? Now, looking at this, I always check it after you graph too, but you can kind of predict what your range is going to be here. What's your range going to be? What goes around 1? Because it's going to be approaching that 1 value. Bless you. Alright, so now I'm going to use my table. And I'm going to plug what values in, guys? Very good. I'm going to graph that. Oh, look, I already put it in there. And I get 1.125, 1.25, 1.5, 2, and 2 is 3. Alright, so I'm going to graph it. And that would be my graph. Now, let me tell you what I would mark wrong. What value is it approaching on the Y? If you went below that 1, like you went under that 1, I would mark that wrong because it's approaching that 1 value. Does that make sense? So be careful with that. Don't get in too big a hurry and say, whoosh, just swoosh it over there. It needs to follow that asymptote, that horizontal asymptote, okay? Alright, then I make sure my domain and range agrees. Yep, we're good. Alright. Now, we also talked about the natural exponential function and learn where that's at on our calculator. It's called natural exponential. Is the number e. It's not a variable. It is number e. What is that approximately equal to? 2.72, and sometimes you see 2.7. So just know 2.72 or 2.7. All right. You said, Mr. Chester, what if you ask that on a test what you want to put? 2.72, 2.72, 2.72. Because pi is 3.14, isn't it? So I like the 2 digits, 2.72. Okay, so where's E located? If I, right above the natural law, so I'm going to hit, and that is what E to the 5th would give me, 148.41316, whatever it tells you to round in your fractions. Here, if I was typing this in, 3, and that would be my value for that. Are we good on how to type that in the calculator? All right. We're about to go over homework, but first let's go on and look at the picture. Before I've already got all the graphs drawn for you to check. But if I give you a graph and you want to write the equation, which point would you go to find? The 1 right here. It's 1, 2. 1, 2. So I would write y equals, put my x there. What would be my base, 1 or 2? 2, because if I plug 1 in, it's got to give me that, don't it? So that would be, so Mr. Are you going to give us harder ones than that? No, I'm going to give you something like that. Even if I put one on the test, I don't know if there's one on the test like that. All right, now let's look at our graphs. You can check your work here. I look out here on number 1. There's not a number sitting there, so it should be approaching what value? 0. So that's where my domain and range, like that. Now you say, Mr. Chester, that's a whole number. Why is it not growing? It's decaying. Okay, what does that negative have effect on that graph? It reflects it about the what? The y-axis. So that's why I'm saying you might predict this, but you always need to check it after you graph it to make sure you were correct after the graph, just in case you forgot about one of those. Number 3, I have a fraction, so decay. That plus 1. So my range would probably be approaching what value? 1. And you can check your table to see. Number 3. I looked. It looks like growth, but that negative catches my eye and I say it might be decay in here because it's reflecting. So just keep that in mind. This plus 2, that has an effect. It moves the graph up 2, the parent graph up 2, so it's going to be approaching 2. So I'm going to draw it very close to 2. And then I use my table values. I always use -2, -1, 0, 1, and 2 to help me graph the graph. And why do exponential functions usually give you some big numbers? Because it deals with what? Exponents. Don't exponents get big quick? Okay. All right. Like number 4. Plus 4. That's going to have effect on that range. So it's be approaching 4. You said, Mr. Esther, can you make us graph them to 36? No, I just do that so you can see. I want you to see the whole thing on this. But if you had went below this 4, I would have counted that wrong. Okay? Do you understand that? Are there any questions on your homework? Okay. Let's turn to page 2. We're going to graph them. We're still graphing the same way, but guess what we're going to be graphing with now? The E, the letter E. So we're going to do a couple of these. We're not going to get bogged down on this because it's the same process. You're going to use your calculator, blah, 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 everything. Alright. So I'm going to write a table. What values I'm going to put in there?
-2, -1, 0.
Very good. So I'm going to input that plus 3 is going to have an effect on my range. It's going to be approaching 3. I look at my calculator, indeed that is what's happening. It's approaching 3. Go to my table. 3.1, 3.4, 4, 5.7, 10.4. I might not get 2 and 10.4 on the graph. Now E, remember, E is approximately equal to 2.7. So naturally it should be doing what? Growing. It's not less than 1. That's a fraction. That would be decayed on. So did it support our growth model right there? Yes, because E is larger than 1. But when you do have stuff like this, transformation rules will make it look like decay, but naturally it's growing. What's your domain? All real numbers. Your range? 3 to infinity. Now, is this -2 going to affect the graph? Yes. Is that negative x going to affect the graph? Instead of growing, it's going to be what? Because it's reflecting across the y-axis. Does that make sense? Okay. All right. Look at my table. Getting very close to negative 2, but it does not touch negative 2. So my domain will be all real numbers. My range will be negative 2 to infinity. Now, if you look at your table, guys, and you start to see negative 2, what happened in the table? The fractions got so what? Small that it just eventually rounded up to negative 2, but in fact, it never did touch negative 2. Alright. And you do the last one the same way. I'm not going to go into that one. We did 2 of them. I think we're good at using our graphing calculator. So what we did yesterday and today was learn how to graph exponential functions using the calculator. Talk about transformation rules, what they should look like, what happens with you have a base of a whole number versus the base of a fraction. How do you feel my first learning target? I need a hand signal. Okay, thank you. Okay, we're going to one of my favorite things now. Turn to page 3. Logarithms. Love them. Love them. I do too. But we're going to start with something different. We're going to start down here at number 9. We're going to do 9 through 12 first. That should have came to get them. Because it's talking about the relationship between exponential notation. And when I say the word exponential notation, that means you're writing using exponents, okay? And when I say logarithmic notation, you're writing it using log. So let's look at the relationship here. Exponential is 3 squared equals 9. In logarithmic, what's that number known as? Your base or your exponent? Base, that's your exponent. The whole thing's called a power. Base, exponent. 3 is the base. Do you see that little 3 over there? That's known as the base. The way we read this is log base 3 of 9 equals 2. Log base 3 of 9 equals 2. Let's say it together.
Log base 3 of 9 equals 2.
Okay, so if 3 squared equals 9, this is how the relationship. 3 squared is 9. Okay? So I want you to write these two in logarithmic notation here, 9 and 10. Write that in logarithmic notation. So it would be log base 4 of 16 equals 2. Log base A of C equals B. Now, let's take these two logs and put an exponential. What would the first one be? 7 equals 49. Very good. And then A raised to equals B. All right, going back to the top. This basically says, if you see this format, what power of B gives you what? X. Okay? Now, take a break from the note-taker and look up here. Let's look at these 3 right there. Let's talk about these. Log base 6 of 36. What power of 6 gives you 36? 2. Okay. We know the relationship between 6 and 36 is 6 squared is 36. We know that. But we have a fraction there. So my question would be, is it going to be a negative exponent or a fraction exponent? Negative. So what would you put there? Negative 2. Now here it says log base 36 of 6. Now the relationship between 36 and 6, I'm taking the what? Square root. How is there a way that I can write a square root as an exponent? 1/2. So if you're going from if it was the cube root, I'll put 1/3, wouldn't I? So remember, there's your situations. You can have a pretty whole number, you could have a negative number, or you could have a fraction exponent. Remember, if it's fractions, I'm not going to have two fractions together, that's how I remember. Here, if I'm going from something big to small, you're going to be taking the root of something, okay? Are we good on that? Okay? So on number 1, it says find the exact value. Oh, on this part of the test, there will be no calculator use. This will be a section on your test. I haven't decided yet what day it is next week. Probably Friday. You would do this part first, and then I'll give you the rest of the test. But okay, so 5 to what power gives you 25? 2. Now, if the base is not sitting there, what do you remember from algebra? It's understood to be what? 10. And anything that has a base 10 is called a what type of logarithm? Y'all remember that? It starts with a C. Common. Very good. It's called a common logarithm. If there's not a number there in the base of a log, it's understood to be 10. Logarithms with base 10 are known as common logarithms. You need to know that vocabulary. All right. 10 to what power gives you 10,000? 4. Very good. Because you got 4 zeros. That's how I remember it. What's the relationship between 49 and 7? You're taking the what? So what would that be? 1/2. Very good. What's the relationship between 6 and 216? It's 6 what? Cube, but since that's a fraction, I'll put what? Very good, guys. Very good. Now, I'm going away from that for just a minute. Look at this. What's my common base? There. 10. Does it help you in that form too much? How can you write 0.1 in another way? 1/10. Because that 1 is sitting in the 10th place, isn't it? How would you rewrite this one? 1 over what? Okay, don't let those be tricky to you. So 10 to what power gives you 1/10? -1 would be your answer there. 10 to what power gives you 1 over 100? Okay, you're going to see stuff like that. I just want to make sure you are aware of that. Does that make sense? Are you sure? Okay. All right. Last 4 examples. Now, the whole reason we study these together, just like adding, what's the inverse operation of addition? What's the inverse of division? The inverse of the exponential is logarithmic. That's why we studied the same thing. So logs and exponentials are inverse operations. So let's look at these two. These are the easy problems. Let's say that you have the same base here, and then you had something raised to an exponent here. If those numbers are the same, what happens to them? Cancel, and it's just left with that x, whatever's sitting there. Okay? For example, you see how I have a little base here and I have that base right there? Those 5s will cancel out and you're left with 4. That's that property. Here, if you have something raised to a log that has the same base, for example, let's say I had 3 here and I had a little 3 here. That would cancel, leave you x. That's what that property states, okay? So that would just equal x. So right here, on number 5, I do not see a base there, but what will be my base there? Those 10s are the same number, aren't they? So what's your answer? 16. What's your understood base up here in this log? 10 and 10 is the same, isn't it? So what will be your answer? 7. These 3s are the same, so your answer is 12. Now, if you're dealing with a natural exponential function, the number e, Are you going to see log or are you going to see natural log? Natural log. Okay? So what's your understood base for this natural log? E. So what happens to these e's? So your answer is 8. Y'all remember that from last year? Okay. Turn to page 17 in your notebook right now. Page 17. Alright. If you look at your assignment, these 4 are graphing. Don't do those right now. You have to do this right here is what we just did. Can you just knock that out of the park right now? Do 16 to 34 now and be done with that. And then go back and do the 4 graph. You can do 16 to 34 on that piece of paper, but the graph's going to have to be done on graph paper. I want you to knock that out of the park right now and be done with that. We were going to do graphing laws today. We're going to save that for Monday.